Welcome to today's lecture. Today we'll be basically discussing the basics of digital multiplexers. So let's move on to the next slide. Now, what is a multiplexer? Now, basically multiplexer is otherwise known as many into one. That means it is having many input lines, and those information available at the input lines are serially transmitted into the output lines depending on the selection inputs. So a simple multiplexer may look like this. This is a 4-line 4-to-1 mux. So since this is a digital multiplexer, so depending on the inputs, the number of inputs, there is a relation with the selection inputs, and we'll see that. And the inputs here are given as I0, I1, I2 and I3. So depending on the selection inputs at S1 and S0, the inputs will be selected at output. So from here we can see there are many digital inputs and only one output. And let us try to designate the input lines by M and select lines by N. Then the relation between these two will be 2 to the power n is equal to M. That means suppose there are 4 select lines, then definitely there will be suppose there are 4 input lines, then definitely there will be 2 select lines. That is 2 to the power 2 is 4. So in the similar manner, if we have to have more inputs, then the select lines will increase. So if there are 3 select lines, then we can have at maximum of 8 input lines. Now let us try to understand how this particular basic multiplexer functions. Now we can see we have 4 inputs, I0, I1, I2 and I3. There are 2 select lines, S1 and S0, and one output which is given as Y. So whenever we have 0 0 at the select lines, which is shown here, the input I0 gets selected at the output. And we all know, since there are 2 select lines, there are 4 possible combinations. So the very next combination where it is S1 is 0, S0 is 1, then I1 input gets selected at the output. Similarly, when the select line is 1 0, the I2 input gets selected at the output, and the next one is 1 1. When it is 1 1, I3 input gets selected at the output. Now one thing we have to remember is the I0, I1, I2, I3 are all digital inputs, and digital inputs here means we can either have a 0 or a 1, or a 0 logic, or a low logic, or a high logic signal at the inputs. So whatever be the input, whether it is 0 or 1, if that particular line is selected, then that particular information will be available at the output. Now based on this, we'll have to find the sum of product expression so that we can implement this particular multiplexer using discrete gates or any other universal gate as per our wish. Now let us see what happens. Let us see the truth table of the 4-to-1 multiplexer. So as we can see, there are 2 select lines and there are 4 possible combinations, and from the previous diagram we have already seen that when 0 0 is at the selection input, I0 is at the output. Similarly, when 0 1 is at the selection input, I1 is at the output. 1 0 gives us I2, I1, and 1 1 provides us I3. Now if we go for the expression, see at the output we can see we have I0, I1, I2 and I3, and we do not know what is the present status of the inputs. So we will be considering I0, I1, I2, I3 in the expression itself. So if we get the sum of product form, we can see it is y equal to I0 S1 bar S0 bar. Since if we consider this, the product term will be I0 S1 bar S0 bar. Similarly, if we consider this particular term, it will be I1 S1 bar S0, and the next one will be I2 S1 S0 bar, and I3, the fourth one will be I3 S1 S0. Now if we use this to get the logical circuit diagram using discrete gates, we can draw the circuit in this manner, where first of all you see both the variables S1 and S0 are in the true form as well as in the false form. That means they are all, sometimes it is high, sometimes it is low. So what we will do is we will use NOT gates to get the complement of it. So S0 into a particular NOT gate provides us S0 bar. So this particular line will be S0 bar. Similarly, S1, when it is complemented, we get S1 bar. Now, depending on the first term, see it is I0 S1 bar S0 bar. So we will require a 3-input AND gate. So 3-input AND gate, one is having S0 bar, another one is having S1 bar, and another input is I0. Similarly, the other product terms are also implemented using AND gates, and the outputs of all the AND gates are odd together. So this can be done using 2-input OR gates, but also it can be done using a multiple input OR gate. In this circuit diagram, we can see we have used a multiple input OR gate, and hence we get an output which is Y. So this is the logical circuit diagram of a 4 to 1 multiplexer having two select lines. So this is what is the basic of a multiplexer. Hope the lecture that we have taken today gives you a very brief idea about digital multiplexer and how that functions. In our coming up lectures, we will be discussing different applications of multiplexers. We'll be implementing different logical circuit diagrams basically used in digital circuits using multiplexer. Thank you for watching the lecture.